Welcome to Make Made Simple. Today we will be continuing from the last video that we had studied, that is friction force on a slanted surface. This is a slightly different case than the previous video that I had uploaded. So in this case we have a mass m on a wedge and the theta angle here the angle is theta, and we have to calculate how large does the angle need to be such that the block begins to slide. So at a smaller angle, if the block is kept at a smaller angle, then it will not slide because the friction force will be greater than the aiding force, that is the mg sine theta. So at we need to find at what angle will at what angle will mg sine theta, this one will be greater than mg cos theta. So we have mg force in the downward direction, and this theta will come here and become theta here, and this will be the mg cos theta, this will be mg sine theta, and the normal force will be in the tangentially upward direction, that will be mg cos theta, and friction force will be n nu s. F frictional is equals to n nu s, and that will be equals to n is mg cos theta, so mg cos theta nu s. Nu s value we are already given 0.5 and nu k value is 0.4. So we have to find at what angle will mg sine theta be greater than mg cos theta nu s. So that's the equations that is to be solved. So mg will cancel out, so we will be left with tan theta greater than nu s. Tan theta greater than nu s. So is that the case? So we have theta will be greater than tan inverse nu s value we are given here 0.5. So theta should be greater than, so this value if we calculate, it will come as 26.6 degrees. 26.6 degrees. So tan theta should be greater than 0.5. That's the value of nu s. That's the value of nu s. So we see that at an angle greater than 26.6 degrees, greater than and equal to 26.6 degrees, if that is the angle, then the block will slide. So that is all for today. If you have learned anything good from this video, please do like the video, subscribe to my channel and share it among your friends. Thank you.